This SOS video is about how situations can be modeled using the arithmetic explicit formula. So just as a reminder, arithmetic sequence is a list of numbers created by adding the same number to each previous term. Explicit formula is a rule that describes a sequence, and you can also use it to find any term of the sequence. So when we model a situation with an arithmetic explicit formula, it's helpful to first write the sequence in numbers. From those numbers, we can easily find the first term and the common difference, which we show as D. Then write the explicit formula using those values. And finally, solve by substituting in a value that you're given for either n or a sub n, and then you find the remaining variable. Remember, when you simplify an explicit formula, it becomes a linear equation in the form of y equals mx plus b. So let's take a look at our first example. A figure has 6 stars. Each subsequent following figure has 4 more stars. So I first ask you to write the first 7 terms of the sequence that represent the number of stars in each figure. Throughout this video, when I ask you a question, you want to pause, try to do this on your own, and then start the video again and see if you did it correctly. If you did not do it correctly, then please correct your work on this paper. Okay, how'd you do? Remember, the first figure had 6 stars, and each time we added 4 to that previous term. 6 plus 4 is 10, 10 plus 4 is 14, 14 plus 4 is 18, and so on. Now you're asked to write the equation to find the number of stars in the nth figure. Remember, our regular explicit equation for the arithmetic sequence is a sub n is our first term plus your common difference times n minus 1. So our explicit formula would be a sub n equals our first term was 6. Our common difference, what we added each time to this was 4, and you would multiply that times n minus 1. We can use this formula to find the number of stars in any figure. So for example, if you're asked to find the number of stars in the 23rd figure, I'm telling you that n is 23. So what you do is you take your formula. If we want to find the 23rd figure, we simply replace anywhere we see n with the number 23. Okay, you can grab your calculator. When I put this in, you know that 23 minus 1 is 22, so then easily to just put 6 plus 4 times 22, and we get 94. So our 23rd figure would have 94 stars. Okay, sometimes you're asked it slightly different. In this case, what number figure is made up of 222 stars? So instead of telling you the number figure, I'm telling you the end result. I'm giving you a sub n. We still are going to use our same formula for the arithmetic sequence, our explicit formula. And if a sub n is 222, in place of this, we're going to put 222. So 222 equals 6 plus 4 times n minus 1. Okay, remember, stop the video, solve for n, and then start it again, see if you did it correctly. Okay, so when you solve for n, we can distribute the 4. Remember to distribute to both terms inside the parentheses. Then I combine like terms. 6 minus 4 was 2. So 222 is 2 plus 4n. Subtract 2 on both sides. 220 is 4n, and n equals 55. That means the 55th figure is made up of 222 stars. Our next example shows a container of juice at a concession stand. The table of values here represents the juice in the container. So our n values show the number of minutes, and our juice in the container is going down as the minutes go on. You're asked to write an explicit formula that represents this sequence. So our explicit formula, we need to know our first term. So f sub 1 would be 126. we need to know our common difference. So remember, to find our common difference, we're going to take any one of these numbers. So say, for example, I take 112. Let me put this over here. Okay, 112, and I subtract the previous number. So minus 126. Oops, minus 126. And I get negative 14. Let's see if that works for a couple of more instances. 84 minus the previous term, 98, also gives us negative 14. And one more time, 70 minus my previous term, 84. Whoops. 70 minus my previous term, 84, also gives me negative 14. So I know that I have a common difference. That difference is always the same number. So my explicit formula will be f sub n, because that's the subscript notation that was shown here, equals my first term, 126, plus my common difference. If I add a negative, it's the same as subtracting, so minus 14 times n minus 1. That's my explicit formula. Okay, find the eighth term. So I'm telling you that n equals 8. So I'm going to use my formula here. I'm finding my eighth term, which is 126 minus 14 times 8 minus 1. Okay, you can put that right into your calculator. 126 minus 14, and 8 minus 1 is 7. And that gives us 28. Okay. So that means in 8 minutes, we will have 28 ounces of juice left in the container. That is what it means to represent in context of the situation. So in 8 minutes, there is 28 ounces of juice in the container. Would a 20th term apply in this situation? Well, let's see. What happens when n equals 20? So remember, pause the video, try this on your own, see the answer you get, and explain if this would make sense in the situation. Okay, and let's see. When you put 20 in the explicit formula, you got negative 140. So that means a 20th term would not apply to the situation because you cannot have a negative amount of juice in a container. You can't have negative 140 ounces in a container. Now I want you to simplify the formula found in A. So when I have f of n, I can write that as y because that's our output. When I have n, I can write that as x because that's our input. Okay? What I'd like you to do is simplify this, and then let's see what this new information is showing us. Okay, when you simplified the equation, we ended up getting this in y equals mx plus b form. So we already knew from our common difference that our rate of change was negative 14. That for every minute that went by, we had 14 less ounces of juice in the container. And that's our rate of change here. But what didn't show up in our table is our constant. Remember, this is our y-intercept, and our y-intercept shows us the initial amount in a situation. So initially, there was 140 ounces of juice in the container. You didn't have to simplify this equation. What we could have done is instead of subtracting 14 to go forward, we could have done the opposite, added 14 to go backwards. So if I go back 1 here, that would be 0 minutes, our initial amount. And if I, instead of subtracting 14, add 14, I would get 140. So this would show that the initial amount of ounces of juice in the container was 140. But by simplifying our formula, we will get the same information. And that is how the arithmetic explicit formula helps us represent situations and solve for information that's needed.